So I hope you have your notes out. I've put some key terms here that I want you to make sure you have in your notes so that you can refer back to them if you ever have any questions about the atom. So the atom, smallest building block of matter. You can't divide matter any smaller. Everything is made out of atoms. The nucleus is that dense center. And so here we have in the Bohr model that nucleus with your protons and your neutrons, and it's that dense center. Protons, positive. Their mass is actually really, really small because remember, atoms are teensy, teensy tiny. We can't see them with our eyes. They're too small. So the mass of a single proton is 1.67262219 times 10 to the negative 24 grams. This is a really, really small mass. We use a different unit than grams most of the time when we're talking about these teeny, tiny, tiny, tiny masses. We use a unit called an AMU. So we're going to talk about the neutron real fast. That's this neutral, no charge particle found in the nucleus. Its mass is really, really small as well. You'll notice this, it is slightly higher than that of a proton. But if we round it all up, its mass is still approximately 1 AMU. And so its mass is fairly close to that of a proton. And then we've got our electrons. They're found on the outside, kind of orbiting. Now, when we get to charge, you'll notice the charge of an electron is -1. So it has an oppositely equivalent charge to that of a proton. But when we look at mass, it's really small. It's 0.000549 AMUs. It's much smaller than that of a proton or a neutron. So here's an analogy that might help you think about this. Hey, I've got a job for you, $20 an hour. Are you interested? And you might be like, yeah, $20 an hour, that's great. That's like the mass of a proton or neutron, right? $20 an hour. Okay. Now your other friend comes up and they're like, hey, I've got this really cool job for you. I'm so excited to offer it to you. 1 penny an hour. You gonna take it? Probably not. Because the mass of an electron, like that 1 penny an hour job, is just virtually insignificant. It's like not getting paid at all. And so when it comes to the mass of an electron, we just ignore it. We don't really count it because it's so small that it's virtually insignificant. And so hopefully that will help you remember how when we're talking about mass of an atom, we'll look at the mass of the protons and the neutrons, but we don't care about the electrons. Atomic number. So we talked about this a little bit. Atomic number is the number of protons. So here in this one, we've got 1, 2, 3 protons. Atomic number 3. The properties of the atom are determined by the atomic number. And so when we organize things in the periodic table, we can know kind of what characteristics or properties those particular elements will have because they're organized by the atomic number. Make sure you have this chart jotted down in your notes. Quick review. Electrons, mass insignificant. Protons, neutrons, mass of 1, AMU. Electric charge. The electric charge of an electron is 1 minus. It is equally opposite to the 1 plus charge of a proton. And neutrons, no charge. As far as location, electrons are found outside of the nucleus, and protons and neutrons are found inside of the nucleus. So I'll give you about 10 more seconds. You can pause the video if you need to and finish jotting that down. All right.